Hey everyone, welcome back. It's a new year and we are ready to dive straight into Solidity Fridays. We will be doing this weekly, and today we have a super exciting episode. We're welcoming back Tamara Ringas and Ryan Noble. So they're both instructors for Web3 Sanctuary and super talented. And if you guys want to give an introduction, I don't know, a little background to yourselves, feel free to hop. Tam, maybe?
Yeah, sure. Hey, I'm Tamara Ringas. I'm a Solidity engineer at Alchemia, and I teach Solidity at Web3 Sanctuary. I also do some zero knowledge as a side interest.
Yeah, thanks.
So hi there, my name's Ryan Noble. I've been a blockchain dev since about 2018. Presently working at ChainSafe, but I've been involved in Web3 Sanctuary for a while, and yeah, I've worked in a lot of different contexts, from advertising to gaming to IP-based storage. So yeah, it's not random.
Cool. And today we'll be looking at the new EIP Collateralized NFT standard, which is super exciting. So Tam and Ryan are going to go through all of the documentation and see what they find. So let me add the screen share. And
Cool.
hand it over.
So 14 days ago, Hippocrates 555 suggested a new EIP. The proposal recommends an extension of EIP 721 to allow for collateralization using a list of EIP 20 based tokens. The proprietor of this EIP collection could hold both the native coin and the EIP 20 based tokens, with the token ID acting as the access key to unlock the associated portion of the underlying EIP 20 balance.
So I was having a look through this, and I mean, I didn't look at the code yet, but so it's a Ghost protocol that I think is using it for the Envious House, or because it's a 721 Envious.
Yeah.
Yeah. Now if I read this correctly, right? So like that allows you to do sort of like a token issuance to essentially NFT holders that you got. So like, what would be a typical use case that we look at?
Well, maybe you could put almost like an ESC 1155 or something like that. You could use a 721 NFT as you can put collateral with it, and then use that as like an NFT that's transferable, and then you can take the collateral out. Or what are some use cases you thought of?
So I tried it. A lot of them started just sounding like I'm doing a DAO with weird steps, but like, so like what can be nice, right? If you're thinking from a gaming context. So I mean, this is a bit. You'd have to do something like running it on OP or something. But like, if you own this NFT, and imagine we were doing Farmville, right? You can actually then issue your crops, so to speak, as the fungible things there. But that was the most contrived example I could come up with, and it was I've been looking at too many games right now. But from like a more simple perspective, I think like just owning the actual token, like. Sorry, I'm getting errors on the side of the chat box. So yeah, I'm not too sure if there's like a very user focused side. I mean, have you got the Ghost NFT light paper around?
Yeah, I can get that. This is the implementation, and here's the light paper for Ghost NFT. And maybe we should also look at their docs.
because the way that's being used here is to allow them to have a lot of interesting mechanisms to design around, but I think it also it allows them to do interesting things when it comes to the bridges from my understanding. They have an entire game theory section at the bottom here, but
that's cool. And I see they also integrated with their Ghost DAO.
Yeah, so it's so they got the Ghost DAO, they got like the bridging system, but what I did appreciate is that the way that they did the sort of game theory representation. I mean, like it's very light, but like at the bottom, yeah, that little grid over there, number 19. Yeah, so
cool. So there's 18 and 19. I see. So players are expected to bridge when they anticipate an expansion in supply due to earning a higher Ghost DAO staking APY on a different blockchain, or earning Ghost block rewards in addition to Ghost DAO staking APY rewards on the existing blockchain. Okay, so it's speculative. You can also use it to like speculate on the value of the underlying tokens that it's collateralized with, I think.
Yeah, so they also have like multiple ways of managing the distributions, right? So they have this one dynamic one that can allow you, random one, which can allow like the issuance of tokens to these different NFT IDs to be based on like say a chain in VRF for like raffles.
That's cool.
You know, so, yeah, like it's actually nifty because you could do like tickets and things like that.
That's very cool.
I mean, in a way, you could, I suppose, like imagine Pool Together didn't exist yet, and we saw this, and then I buy. I suppose it's the wrong way around, but instead of just shoving tokens in there and having it tracked, you could actually just buy a raffle ticket in this Pool Together thing, and the VRF just randomly issues the tokens to that NFT ID.
Yeah, that's cool. And then is the other one non-random? That's for like maybe the bridging.
Yeah, so I think, let me see which page it's on. I think they describe it on page 10.
Cool. Yeah, I'd also like to look at their architecture on 13.
Yeah, so 10.
Okay, so this standard enables creators.
On page 11, yeah. Yeah, they got like a grid version. Hooray for pictures.
Oh, I see. So there's 4 different types with obviously the base is just the one we described in the EIP. A royalty preset. That makes a lot of sense. So I would have an NFT, and then people pay my royalties in ERC 20s into that 721, and then I can just use my key of that to unlock and get the collateral that's underlying. That's cool. I see they have some fees: a transfer fee, a collateralization, and an uncollateralization fee. It's weird. That's the only one that has a transfer fee. The other, the VRF doesn't.
Because it's a royalty concept, right? So like in terms of swapping ownership, there would be a fee.
Oh, I see. Okay,
yeah.
Nice. That's cool.
But yeah, then they got like the VRF and the dynamic one. They kind of go into a bit more detail. So you can like design. I mean, we'd have to look at the code in a bit, but like the idea is that you can sort of roll your own logic when it comes to the different mechanisms they've messed around with up top there. And so like if you scroll up just a bit.
Yeah, sure.
So you got the VRF preset. So like they actually give an example there. They got like the raffle one and the giveaway one where it's like total volume is issued to 1 token. Then they got the raffle that just YOLOs it. Sorry. Giveaway is more like airdroppy, I guess.
Yeah, selected set of wallets. I see. That's cool.
That could be interesting. So you know Xeron, the wallet, the portfolio tracking system.
Yeah.
No, I don't.
I do, yeah.
So they're like basically you plug in your accounts, they check every network.
Sorry, I do. I just had to like spell it in my head.
So they started doing like NFT gamification a while ago, and this would be brilliant for that, right? So like because if you're thinking airdrop for an app, you might as well start with giving them like, a little achievement badge for being a first-time user or like being an OG or something. And if you have this on like as the foundation, you can do all of that issuance kind of directly just to anyone who happens to have this achievement, so to speak.
Wow, that's cool.
We have a question, but I'm not sure if you want to answer it now or later. So it's, can you explain the process of using an NFT as collateral under the standard?
Yeah, sure. Maybe we should look at the code for that.
Yeah.
Yeah.
And this is a nice explainer in this white paper.
Process of using the NFT as collateral. So the idea, I think if I interpret that correctly, it's like, how would you utilize the NFT itself as collateral outside of the contract, or
maybe they're misunderstanding. So the collateral is the ERC20s.
Yes.
And then you link them with the 721. And I guess they're asking how we would do that. So maybe we should look at how a real ghost chain to implement it in their envious ERC 721.
Yeah. So
this is the repo with an example implementation. And if we come back here in the docs, so it's not just, this is the one implementation, but there's another, this NFT collection also implemented this EIP.
The John McAfee Legacy NFT collection.
Oh wow, these docs are quite extensive. So here's the extension.
Yeah.
So this is how it's done. Let me zoom in. So it's an abstract smart contract that extends the functionality of ERC 721 by enabling the collateral features. So that's the contract we have over here. We'll look at soon. And then, so the address of one of these NFTs stores the native token and ERC's 20 tokens, where the token ID serves as the access key for unlocking the corresponding portion of the balance. So you need to have a balance of that token ID to get the ERC20 balance underlying.
In a way, this is a very interesting way to do sort of access control on like distributed funds. And also, with that in mind, you could also do it revocably, right? So like if you have NFTs that are meant to represent merely access, right? Like say you have, that's why I keep start thinking about DAO stuff here, because say you issue out controller rights of like an on-chain game, and now I'm admin, I have admin NFT. You could then perhaps control just by like the dynamic preset, for example, how the inflows and outflows there. But yeah, it feels like a lot of access rights could be kind of thought about with this.
Yeah, that's very true. So how it works is this extension, so it's obviously an abstract contract, so you would instantiate it when you use it with yourself. But the ERC 721 has an array of token addresses associated with its ID, and then you can add any number of ERC20 tokens to the collateral address array. And then this is cool. When a balance of a specific ERC20 token drops to 0, its address is removed from the array of token addresses.
I suppose because the contract is the controller of balance transfers in that case.
Yeah. Cool. And then there's a disperse token. So you can send all assets of all types in the collection in a single transaction. And to do that, they store the collateral in a temporary variable. Okay. And then they only, when you do the collateral change, does it the collateral balance change. And there's an interface. Maybe we should actually start by looking at the interface on in GitHub.
Yeah, I think so.
That would be nice.
10 months ago.
Yeah, it took them a while to make the ESC, EIP improvement proposal.
Yeah, so, such a slide for this one.
Cool. So they're using the Open Zeppelin 721 implementation. Cool. And it's each NFT in a collection. So that's also nice. You can mint a whole collection and each has underlying collateral, and they can be different collaterals. So the events are here in the interface. Collateralized, uncollateralized, dispersed, and harvested. I'm intrigued to see what the scaled amount does. Then there's commissions. So this is an array with 2 elements. Each of them represents a percentage from the collateral to be taken as a commission. First element represents the collateralization commission, and the second is the uncollateralization commission. So they can be different. There should be a 3 decimal buffer for each of them. Yes. Well, that's how that would work. So then you can choose to get the first 0 or 1. And then 0 would be the collateralization commission they're going to take, and then 1 would be uncollateralization commission. Okay, ghost address is the token that will be paid on bonds. Bonding address is the address of a smart contract that provides purchasing of DeFi 2 bonds. So this is also a nice use case that you could get is if someone's doing like a derivative or like a fund like that where they want to like hedge against something, you can collateralize an NFT and then access it later. So that's kind of, I think, where these bonds type of thing would come in. Okay, black hole returns the address of the black hole. So that's like a burner address.
Yeah, it's for ERCs that don't have burn features built in. So they're just like...
Yeah, you just send it there and dump. Makes sense.
Yeah.
Cool.
I am quite curious what exactly they were, like, what was the problem that they were specifically dealing with that led them to committing to making an entire EIP out of this?
I'm also curious. Yeah.
We can get to that later, though. But
that would be very interesting. Okay, then you can disperse tokens.
Oh, sorry. No, just before we go into the next part, there's a follow-up question as to how is the value of decollateralized assets like native coin and ERC20 tokens assessed and managed over time, especially given the volatility in the crypto markets?
Right, we can check that in the code now, but you just have a balance of the coin. I don't think it has like it displays the actual value. So you'll
might
have
be meaning in the case of the bonds, perhaps.
Oh, yes.
And this also begs another question. How on earth do you value these NFTs? Like, you can list them.
Yeah.
Right?
Yeah,
these
you can just
work
whatever.
But could you imagine trying to do the price feeds for this? Because, like, every token ID has a non-matching amount of...
Yeah. Yo, that would be tough. So here you can see the bond payouts that you would get. So we should look at this function when we go to the code, which maybe we should do now.
Well, we could even dive into the tests and see what exactly they're going on about.
That's quite a cool idea.
Yeah,
maybe we just take a peek at the
Okay, so they actually keep the presets in a separate... I suppose that makes sense. But
So this would be so you would want the base preset of the dynamic or royalty or VRF. So we'd probably want to look at the base.
Yeah, so I actually think, so this would be the default one.
Yeah.
So I think like if you're looking at what exactly does this do.
Maybe we look here and then we look at the tests.
Yeah.
Wow, look at the size. They just made it. That's crazy. This is a big contract because it imports a lot. Okay, cool. So the access control enumerable will be, I think, if you have a balance of this token ID, then you can access the collateral. But if not, then not. Cool. Some state variables and roles. Minter, pauser, ghosty. The constructor has a token name, symbol, and base token URI, just like any ESC 721. Then they set up the roles to be the message sender who deployed. Receive, obviously, would need, and it's got to be payable so you can get ETH in. And then, so let's say I put ETH into this. What does this internal function do? Oh, it's
so disperse, and if I remember the minor flashback earlier, I think when you disperse your token address 0, it's considered
burning. I see.
Native token. No, native token.
So native. I see.
So you'd have address 0 added to your token ID's sort of token array. So because the array is like empty. So if you had address 0 and say like you got 2F or whatever. So yeah, this is it didn't actually describe much, well, at least comparatively in detail, describe how the base preset in this case is like different to the others. So
well, I assume this is just what we were talking about with like tickets or not even tickets, but like you just want to collateralize in a 721. Interesting. It has pause and unpause functionality. Set ghost addresses. Okay. Just looking for that function where they would set here's a disperse. So it's virtual and overridden, but you would also override it and make it external. So what does it do?
I suppose because like around your disperse thing, you could have if you're doing ticket sales, you could actually be like actually I might have my steps mixed. This is why we need the test. But I think the main idea, and we'll probably see this in the other presets, is that they've wrapped this and modified it to some extent.
Yeah, cool. Okay, cool. Yeah, let's look at the tests. I think you're right. And then this is the contract that they linked.
Yeah.
So let's look at the NBS House test, maybe.
Yeah. Oh no, the maybe let's. Well, actually, we know exactly what. Yeah. What, like raw? Oh wow. Oh my.
That's crazy.
Okay. Okay, so this they just check that it is a normal 721 compatible. It has the metadata enumerable. Then that access control to check if you have the token ID or not. That's these two, pausable, burnable. Okay, ESC 721 envious.
I mean, given that most of it is like virtual and stuff, unless you're testing your abstract virtual contract, so I think you're right. We should probably just go straight to the NBS House test. Nice.
Cool. So let's also maybe open NBS House, the code, and we can jump between the two.
Yeah.
Sorry, NBS House here. Cool, a bunch of mappings, a bunch of private constants. Cool, Cool. So let's check these tests. It's been a while since I read a JavaScript test contract.
Yeah. But it's even more impressive when it's done well, because like, there's a lot of some tactical niceties that come with your IDE actually talking to you about stuff.
True. Just want to look at the constructor. So you put in the address of the black hole and of the minimal ETH amount. Then the initializer sets a message sender, so that'll have certain rights. You set black hole address to that address, and you have the register amount to register this NFT. So quite a simple constructor, just 2 parameters. I'm surprised it doesn't.
I'm very curious by all those strings.
These.
Why on earth are there so many strings?
It's weird. It's like strings for like reverts. Like it's almost like if they require. Are there any requires?
Wait, 10 months ago. Wait.
Yeah.
I was just going to say 10 months ago. Is that when? I mean, there's also no like custom errors here, right? Like
no, only requires.
Like because it mentioned the size of the contract, right?
Yeah, that's interesting.
They have a lot of strings, like.
Yeah.
If that isn't being referenced on chain, and if it is, they could have probably have made it more efficient with the hash or something. But like,
the hash would have been. See, so it's also just used for requires.
Yeah, so they could probably cut down like most of the storage just by using custom errors.
Yeah, absolutely. That's interesting.
I mean, no magic strings, cool, but like, dang.
Cool. Just want to check something. Here's a bond payouts, but how does it calculate? Oh, it's a mapping. But where does the mapping get updated? Probably when you put the token in and when you try to take it out. So if we look at this as well, take token ID.
So if we check here, that it's basically 2 separate logics for like whether the other thing is an envious or not.
I see.
But so bond payouts collection token ID, that I'm assuming is just a uint, probably. Yeah, it's a uint.
Yeah, must be.
So the one is calculated at the target, whereas
this one's just the mapping.
So my first thought, just looking at this, because so it's just a view. Never mind.
Yeah, so this is just to see your bond payouts, and then I'm sure if we, wait, here we go. What's this? No, this is discounted collateral. See, so here they update that payouts mapping. Where do they? These are all the internal, the privates now.
So we do have a question in the chat.
Yeah.
Yep.
Just pull it up quick.
Yeah. The question is, what happens in the event of a default? Like, how is the NFT liquidated?
I don't know if it can default because it has the tokens inside of it already. It's because it's collateralized, so the collateral's already been paid in.
Might be in reference to the bonds.
Oh, again, the bonds. The bonds are confusing me.
I think the bonds have, but it is part of the spec though. So, oh wait, no. We're actually looking at the implementation of the spec.
Yeah, this is the implementation. Yeah.
So I think this is more to do with Ghost DAO and their bridging bonding system. So I think
so it might not be a normal.
Yeah. So I think it's more bespoke to their systems, and I'm assuming that they wire. Yeah, we'd have to look a bit more into their own game theory there. But okay, so what?
Maybe
what
in
we,
the in here we could go to bonds in these nice docs. Just bond maybe.
Yeah, I mean, we got that from the contract itself anyway.
Yeah.
Well, perhaps I mean, there is the NBS House contract, so maybe they might have a bit more, nuanced context.
Ghost bonding address.
But it's bond payouts though, so
Yeah.
is that necessarily?
I wonder if this bond is like from the DAO, like it's not actually a normal like derivative. It's
So I think these these NFTs are meant to indicate your like entitlement to the sort of payouts of the bonds. I don't know if they themselves manage the bonds. Because like from my understanding, the core of this is instead of distributing to a list of addresses, we can distribute to a bunch of token IDs because you can.
Yeah, and then you can just get that token ID with the access.
Yeah, so like in the same way that you have an option and you can like sell that to something, you could in theory migrate or sell your rights to this ID that then entitle you to certain payouts and down the line derivatives or something like that.
And these payouts are in ghost address token. So
I suppose that,
and there's a vesting period. So it's almost like a
suppose,
like you said, an option could work.
I mean, bonds typically have some form of time mechanism in usually anyway. So
yeah, an agreement of like a fixed period.
Yeah.
Interesting.
I think so. So what I'm trying to figure out is like, what is the I don't know.
So you put in payments in any token address, like ESDC, and then you can get a bond ID. So the bond is just an extension of this EIP 721, collateralized NFT 721. Okay.
They must have an app out now, yes? Like, or is it all on chain for now?
Yeah, I wonder.
Let me take a squint.
Seems like it's just the contract. But let me also look at if you go to their repo.
Yeah, that makes sense. Okay, so if this is what I think it is, they may need to update the security certificate. Or there's a lot going on with the search. Okay, cool. They got Apple coming soon. So it might be sort of alpha or like internal testing.
Yeah.
Is it?
Yeah, it looks
because
like
if you got bridging, you got to test the living hell out of it. So
yeah. So the contracts are available for now, but I don't think they have an app with a front end yet.
Should we take a look at the NBS House test then?
Yeah, that's
have
here.
how far did we make it?
So we're setting it up, and then I got distracted by the constructor. Cool. So they're still setting it up, and then you mint the base token and approve it to be sent to the collection house address and house address, so they can send the space token. Cool. This is just to check this was all set up correctly. This is correct. Collections mapping is correct. Cool. So there's no logic yet. Oh, that's cool. It checks if it is a 721 address in the collection. That's cool. Yeah. Yeah, so this is where the logic starts. So when the ghost address is one of them has a balance of 0, then that gets removed from that array. This is checking that.
I suppose because you're doing balance queries every time there's something in that array.
Yeah, to save gas and lookups. Yeah, same for bonding address. Could see code addresses from initialize. Yeah, so there's that initializer with underscore in the constructor that gets set. So only that person can set the ghost addresses. Cool, collateralized function. So we have a community token. We make a new ERC 20, and then we have 721. That is called bad collection. Then you register the collection.
So all of the collateralization tests have a community and a bad token. Bad collection.
Interesting.
Oh, wait, hold on. So we only have a bad collection and they have an underlying community token. Well, let's see where this goes.
Cool, then they register the weird for, so you get 100 to community address, and then
well, they have a 3-piece decimal, 3-point decimal, yeah, so that's like 1.
Yeah, that is 1. And then 0, and then so here where it was 0, it's probably going to revert. No token committed.
If I remember, the 0 address there is that's just setting the black hole address.
Yes.
Yeah.
Because we had that check earlier to see if it is 0, they just send it to black hole address, which is set in the constructor with token. So now this is probably this one where we have 1 token in the collection. So we it reverts because this one doesn't have a token. And then this also reverts because no collateral tokens, because we have no collateral tokens. Then, oh man, I keep bringing this up, sorry.
So collateral balance. So let's see so we expect that just to
be.
So
Okay, yeah.
Balances. Oh wait, what do we expect? That's just
because it hasn't been collateralized yet.
Oh, right.
Community balance should be 0.
So that's So this is a state checks.
Yes.
All right. So
now we collateralize
collateralizing the house
with the token and an amount with the base token address, and this is the basic collection address. And now we check. This must be their fee taken.
Yeah.
I assume. And that looks like a 10% fee.
Yes.
So new balance is the new. Oh man, stop this. New balance. You just take away what was taken and check that adds up, and that does. Cool. Then we check that the community pool still 0, community balance equals taken. So now we've actually got a community balance. And the collateral balances, it should be new balance. Yeah, that makes sense. So we've transferred it now to the collection, and then there was a fee taken, which is the community. I just want to see in the contract. NBS House. I want to see how they do that. Sorry.
Also, what happens if I just send ERC 20s to this contract? I wonder
if you can.
There must be
you need to have the token ID, a balance of the token ID. So he has a function. Let's check it out. So it's payable, obviously.
It would be nice if it was just automatic.
Yeah. That would be cool.
But that would, I mean, that would require. Okay, no, that's not.
Cool. So you put in the collection, and there's an address, the token ID of that collection. So you don't want to give it to everyone in the collection, obviously. And then amounts with corresponding token addresses. It's interesting that they don't have a require to check that these arrays aren't too big to run into a gas or like a out of gas issue. So they check
it's
NBS.
also quite unlikely.
Yeah, I suppose.
I mean, like you'd be moving quite a. I suppose it depends on how add collateral the function works. Rescue collection.
So what we do is we first check that it's part of it is an NBS, so this EIP 721 extension, and that uses the supports interface, which is I think from ESC 165. Or was it 173? I think it's 165. So you check that so you check that it's not, it hasn't been, it's not this extension yet. Otherwise you revert. Wait, this is the harvest function. Collateralize. Then rescue collection. Let's see what that does. Oh, so this means it adds it to the collection, like it increments the collection after the require to check if there are tokens minted. It has a total supply, and then it updates two mappings where you add to the collections first, and then it adds. This is just internal keeping for them, I'm sure, to check how many collections they have. Wait, this is disperse.
Interesting terminology, though.
Yeah, it's weird.
Like
rescue.
First thing you do is rescue after checking if what you're dealing with
is actually
an instance of yourself.
Okay, then yeah, we get the message of value. But what if it's another token? Let's see. Anyway, cool.
Oh wait, you can send F and tokens at the same time.
Yes.
Yeah. So
I see. Because yeah, token addresses. So you can do as many token addresses as you want, including. Yeah. Sick. First, okay, cool. So if it's address 0, so that's a burn. Oh no, address.
wait, no, that's F.
Yes. Then you decrement by the amounts corresponding, and then add token collateral. This is probably where it all happens. Where here it is.
Yeah. If the token address is 0, then it's adding the F value.
Yeah. So you again have an address collection, the ID of with the NFT in that collection, the amount and the token address, and the bool claim. So if it's been taken.
That might be for the other presets.
Might be, yeah, true. So we require amounts greater than 0. So to add token collateral, you have to be someone has to own it. It has to be a valid token ID. Then it calls disperse, passing in collection token address and token ID. Okay, should we check disperse?
Yeah.
Cool, it's a private function. Gets the balance by going through this disperse balances mapping and dividing by the total supply. Cool. Plus balance is greater than disperse. Okay, so if there's disperse total taken, token address plus balance is greater than disperse balance, then balance equals this disperse balance minus what was taken.
Implying that I think if an existing balance is there, that it then only adds
Only
the
looks at
required
that.
amount to get it back to the exact same balance.
I think that's what this is doing. And then there's another if balance equals, is greater than dispersed taken, then you get a new local variable amount, which equals balance minus what was taken. And then you update that by amount. What was taken by amount. And then there's this array contains to see if the token address is one of the valid collateral tokens, I'm sure. And then if should append, so this is if that was true, then you do, so all you're doing is pushing the collateral tokens to an array. So that's how they're doing all of this. It's just a corresponding array with the 721. But you need the 721 to access that array, and that array can be stored anywhere and transferred to you when you claim.
Yeah, so basically it's like, it's a key to a safe, I guess.
Transferable key to a safe. Well, keys are transferable, but
a sellable key.
And then you can update these to mappings, which is the collateral balances of this token ID in this collection, and dispersed token total. What's quite interesting is amount over here was balance, which is its balance of the total supply, divided minus what was taken. Okay. Just wondering, because different token addresses will have different decimals. And they never normalize these decimals. And I just find that weird.
Disperse typically means to go to a collection and make it no longer being a mass, right? So if I'm reading this correctly, then so you have the collection, the token address, and then the token ID. But if I was under the understanding that token ID has a unique collection of balances, so are we dispersing the balances from that token ID to somewhere else? Or
we're just updating. Disperse just updates balances in mappings. It doesn't actually move anything. Maybe we go back to Collateralize.
Do you think there's been any audits for this?
I was just thinking that because I brought up the there's a gas reporter, which makes me think they would have. Oh, he has audits. Who by?
I thought I saw a thing.
Oh, just internal audits they did with Mithril and Slither. I'm going through a.
Okay, I mean they got every. Also, I was just realizing in the test that they extensively use this dot insert thing, and I got like some intense flashbacks there.
Okay, so we were here. So we've added now the token collateral. Sorry, put this up again. And false, so that's the claimed bool, I think. And then if there's the message dot value is greater than 0, then you send send value, address dot send value, payable, message sender, ETH amount. I just want to see something. It's been a while since
Oh wait. Okay, so what if you're not necessarily meant to? Makes no sense. Because you would send a token address array with the bounds. You'd specify address 0 if you're depositing ETH. You then specify the amount in general for the ETH, and you'd send the ETH amount to it when you do this, I assume. So why are you then sending that to the message sender there? Perhaps they're routing it through like a DAO contract or something.
Maybe.
Because if a user's just doing this, then I see that as a refund. Am I wrong?
Yeah. I'm not sure.
I mean, there's a lot of other contracts in this, so I'm assuming that it's probably
something along those lines. It would be interesting to see. Cool, and then you can do the same by calling remove token collateral to uncollateralize. These are external functions though, with no modifiers.
Well, I suppose like that means it's callable by anyone, which
so where is address imported? Open Zeppelin utils. It's been a while since I worked with address. Yeah, so it does send it to the message sender. So it is a refund. You're right. Just checking.
I'm very confused now. Like,
yeah, let's go back to that function. Here it is. Well, this is just message value. It's not part of the amounts array.
Yeah, but that's why they got the check there. So if token address, if one of your token balances happens to be address 0, we're now.
It's just, I think what it is. Sorry, it's like you can send 20 or like an amount of ETH to this contract, but if your message of value by accident is greater, like let's say it's 100, whatever.
Right.
Then you refund
I missed the
leftover.
minus there.
Yeah, me too. Gotcha. It's here. Yeah. Okay. That's nice.
Yeah. Okay. Yeah.
They could have said, if there's an excess, send it to our treasury. So it's nice that they send it back to the message sender, and they obviously make it payable to do so. Right. This is really interesting. I don't know what else to look at. I think we've kind of covered most of it. So it's mainly just an array.
The ghost collection after this. We don't have much time.
With the dynamic preset. And I didn't get to read much in here about the dynamic NFTs. Let's just quickly look. But yeah, it's just a normal dynamic NFT.
So the VRF has a Chainlink integration for that. So
yeah, it does.
We want to look at that before we.
Yeah, I don't know if you'll have time to look at that.
Well, I mean, we've gone over most of it. We just have to see like what exactly changes from the base preset to the not base preset.
So where are these? I think it's probably under extension. Here. Oh, wait, we want the dynamic preset. Presets. So what's different? So it's all the normal base extensions. Wow, the construction is a lot more hefty. It takes into 3 arrays. Edge values, offsets, and ranges. Token measurement. I just saw something about that. Currently, for the dynamic preset, collateral is only measured for the token measurement token, but an upgrade is possible to enable checking of all collateral and achieve dynamic token URI. Okay, so this is the dynamic one is just for measurement token. Okay, this is actually quite complicated to maybe cover now.
Yeah, maybe let's just take a look at the VRF because like it's either a straightforward change from the original or not.
You're right. So yeah, it's just using Chainlink VRF2. Very important to use 2 and not 1. Okay, the coordinated address, subscription ID, hash, callback gas limits. There's a prepare randomness. So yeah, extra disperse amount, that's where it starts. So this is the amount to be randomly distributed.
Right.
And then, but they just do a random dispersal. They call a random call to disperse, I assume. But this is just the interface. We can't actually see how they implement it.
So the amount that each of these presets change makes me wonder, because there's, as we just saw with the last one, there's quite a lot that changes, even down to the constructors, and it's like.
And here even it says, like, here it doesn't look like they return that message, the excess ETH, if you make a mistake in this preset. Sorry, what were you going to say?
I was going to say, like, I would need to look at the actual, like, ERC proposal, but it's like, how much of this are they considering like critical, like, reference standard, and how much is actually just suggested implementations of it?
I think this extension is the only thing that's their standard, and it's just an array added to the ESC 721 with the access built in. That's my understanding.
Yeah.
Everything else is just there. They use it by inheriting and like setting up this abstract contract, and then they use it for these presets. But you don't need the presets for the standard.
Okay, gotcha. No, I was had my collections mixed up.
It's been really interesting. I think it's a cool idea.
Like,
yeah, it was interesting to look at it.
Like, it's a pretty. It's an interesting way to, like. I really like the way that it sort of the easily transferable ownership in NFT form is, like, really nice. Like, you can actually extend that to quite a lot of different scenarios, right? Like, imagine this synced up with Safe, for example, right? So now your multi-sig has an NFT, and now that owns a bunch of balances. If you wanted to send all of those individual tokens to, like, another account, like, right, the multi-sig is compromised, let's shift things immediately, transfer NFT.
Yeah,
it's kind of like the backpack idea in gaming, right? Like, I want to be able to just send my backpacker items to another account. I don't want to have to send every single item.
Yeah. Like you said, it's like a key to a safe. You can just pass the key to someone. I like it.
It'll be interesting to see, like, if we shove this in a hackathon, it would be kind of interesting.
Yeah. Maybe an idea for our viewers with ETH Denver coming up.
Cool. Shall we wrap this?
Yeah, thanks, guys. This was fun. Yeah, good to have you on again, Rai. I always have fun learning from you. And thanks for helping.
Always a pleasure. Yeah, it's nice to get back on board with this.
Yeah, I think Rai will become more of a regular host alongside Tam. So that's really exciting. Yeah, thank you, and we'll see you next week for another episode that we will disclose soon. Go. Bye, everyone.
Bye.
Thank you.
You guys.